School Mukono. Welcome to the Bishop Senior School Mukono platform, where we learn a few ideas here and there on the work covered in school. So for this part, we are looking at the work on fractions. As you can see, we are looking at fractions. So we hope that by the end of this session, as a learner, you should be able to describe different types of fractions, convert improper fractions to mixed fractions and vice versa, work out problems from real-life situations, add, subtract, divide, and multiply decimals, convert fractions to decimals, and decimals to fractions. Identify and classify decimals as terminating, non-terminating, and recurring. Convert recurring decimals to fractions. Convert fractions and decimals into fractions as well. Convert fractions and decimals into percentages as well as percentages into fractions and decimals. Calculate a percentage of a given quantity. Work out real-life problems involving percentages. So we hope that by the end of this session, you have learned all the ideas talked about. So as you prepare to start, you should take note that this is a continuation of the work covered in first term. So let's start off on fractions. So this is our topic. What you're required to remember is that you covered place values when studying number bases. So we believe and trust that that knowledge is still within your minds. So we are going to apply it in this topic. Now, let's start off with an activity that helps us to identify different types of fractions. So we want you to identify the different types of fractions that you know of by clearly writing them down. So in our activity, you are required to create cards with numbers. So to come up with different papers, 1, 2, 3, etc. So you're going to have as many papers as possible. Then on each, you write a fraction. So let's take an example that these are our papers, different papers. So you write on each the fractions that you know. However, make sure that on each paper you write a fraction of different type. Don't write the same type on each of the papers. So you are going to write for us different examples of fractions, but be mindful of the fact that we are looking at different types of fractions. So on each paper, indicate a fraction of different type. Then create as many as possible. Create 15 to be particular, whereby 5 are of the same type. So you write 5 fractions of the same type. Then let's say of one type. Another 5 fractions of another type. Then another 5 fractions of another type. This gives us a total of 15 fractions. Now, after doing this activity of writing fractions, you can put your papers in your area that you're studying from. So in your study area on the floor, place these papers and then identify which type that fraction belongs to. So I want you to write that these first 5 fractions belong to a certain type. Let's call it type 1. Then another 5, type 2. Another 5, type 3. So by the end of this activity, you should have known that we have 3 different types of fractions, and from there you should be able to do the exercise. So observe your papers and then tell us what types of fractions are those, depending on the value of the numerator and the value of the denominator and the nature in which that fraction is written. Now let's proceed. Then you will have to do an exercise. From there, we are going to look at converting improper fractions to mixed numbers and then mixed numbers to improper fractions. Start by looking at mixed numbers and improper fractions. So far we assume that you have looked at A over B. This is our fraction, whereby A and B are any numbers. And in this case, if A is greater than B, for example, if you have 5 over 3, in this case, 5 is more than 3. So if you have such a type of fraction, and we want to look at how to handle such fractions, let us look at converting from improper fractions to mixed fractions. That is what we are looking at here. In mixed numbers and improper fractions, but we are converting from improper fractions to mixed fractions. So such a fraction, we have realized that this is called an improper fraction from the activity that we did previously. Fraction, but a mixed fraction is of the form A, B over C. So we have a whole number and a proper fraction. How do we convert 5 over 3 to this form? So we have 5 over 3. Now let us look at how we convert this. First of all, this one is the same as 5 divided by 3. And from what we remember about division, 5 is non-divisible by 3. In other words, if you divide 5 by 3, you will get a remainder. Now, what is the remainder? That's the question. So this is the same as 5 divided by 3. When you divide 5 by 3, you will get 1. So 5, if you remove 3, you remain with 2. So 5 divided by 3, it means you have one whole number, remainder 2. 5 minus 3 gives us a remainder of 2. Now, it means you write one whole number, remainder 2. But this is the same as one whole number, 2 out of the 5. So this is our answer, and this is what we call a mixed fraction. This is what we call a mixed fraction. It has two parts, a whole number and another part which we call a fraction. But that fraction should be whereby the numerator is less than the denominator. Okay, then you can continue and do the exercise in that case. Now next, let's look at operation on fractions. Have learned equivalent fractions before, and therefore this is what we are going to use under operation of fractions. So I want to give you a task of thinking, what do we mean by operation? We have different types of operation on numbers. We can do an operation called addition, subtraction, multiplication, and division. All those are operations on numbers. So we can start with a few operations. For example, if we have 1 out of 5 of 10,000. So they want you to get 1/50 of 10,000. How do you get that? Remember, of stands for an operation called multiplication. So we have 1/5 multiplied by 10,000. Right? So how do we work out such equation? We know that 1/5 times 10,000, so we shall divide 10,000 by 5. Alright? So this one is over 1. So 1 times 10,000 is 10,000 over 5 times 1, which is 5. And this gives us 2,000. Okay. So that is it. Let's look at an activity on how to add fractions in a simple way using equivalent fractions. Okay. Our activity. So we are going to get two different fractions but with the same denominator. For example, we are given, welcome to this edition on addition, subtraction, divide and multiplication of decimals. So basically in this edition we are dealing with decimals, and we are going to see how to add, subtract, multiply and divide decimals. But first of all, before we proceed to any of those operations on decimals, we would like to first of all identify what decimals are, what fractions are, etc. So below you have an activity which says copy and complete the table by explaining how you have obtained the answer. The first 3 have been done for you. So in your table you have the place values given, tens, ones, 10, 100, thousands, and then the fraction required. and then the percentage. So they have showed you the 3. For 10, it means 1 over 10. For 100, it means 1 over 100. And then for 1,000, that's 1 over 1,000. Now, they want us to fill in the gaps in the table given. So I'm going to do for you this one example, then you can be able to do the rest. So in the first example, we have in the position of 10, we have 5. And in the position of fraction, we have a half. Then percentage, we have 50. So how did they come up with these values, and how should we bring in these values? So first of all, the values given, how were they obtained? So looking at tennis, this is 1 over 10. And if you multiply 5 times 1 over 10, you will get 5 over 10. We have already seen previously how to multiply fractions. So if you multiply 5 times the position it takes, 5 times 1 over 10, you get 5 over 10. So it means that the value in this position is 5, but its actual meaning is 5 over 10. Then the fraction we are given is a half. That's the fraction obtained from everything given in these boxes. So if we sum up this and that, we should get a half as our fraction. So let's see. But we know that this can be reduced using the knowledge of equivalent fractions. So 5 over 10 can be reduced by 5, 1 by 5, 2. This is 1 over 2. So we realize that actually this is the fraction given. What does it imply? It implies that if this is a half, we need to add 0, 0, 0, and 0 to get this fraction that we are given. So therefore, in this activity, we shall fill in these boxes. In the position of tens, we shall put 0. Position of ones, we shall put 0. In the position of 100, we shall put 0. In the position of 1,000, we shall put 0. Therefore, this means that we have 0 plus 0 plus, this is 1 over 2. So 1 over 2 plus 0 plus 0. What do we get? We get a half as our fraction, the final fraction. Then, after knowing the a half, how do we convert this a half into percentage? So to get that, we shall get a half, the fraction given, times 100%. So this means that we have a half times 100%. So remember, over 100 means percent. So in this case, we shall have, let's take a look at this, fraction percentage equals fraction times 100%. Alright? So our fraction is a half percent, which is by 2. This is over a half. So this gives us 1 over 2 times 100 times 1 is 100 over 2 times 1 is 2. So this gives us by 2, 1 by 2, 50, which is 50%. So you come in this box of percentage and you fill in the value. Because you have the word percentage, this means this value is 50%. There's no need to put a percentage. So you are required to do the activity for the rest of the numbers. Looking at converting fractions to decimals. and decimals to fractions. How do we do that? We begin with what fractions mean. Sometimes you have a value like 1/2. This means a half. It is 1/2. Next, we have another value like 1/4. This means a quarter because it shares 1/4 equal parts. Next, we have 3/4, which implies 3 quarters because we are talking about 3 equal parts or out of the 4 available parts. Now, etc. These are the names given to some of the fractions that we have. Now, if we are dealing with a quarter, for example, it will mean 1 divided by 4. This is what we know of as 0.25. 3/4 is 3 divided by 4, which we know very well as 0.75. So we have expressed the fraction as a decimal. A fraction as a decimal. So I want you to do an activity and convert the various fractions given into decimals. And I want you to notice about particular fractions in D and E. What do you observe? You are going to observe that, for example, if I have a fraction like a quarter, I have got 0.25. It stops there. But remember, we can have some other fraction. For example, I have 1/11. This is equal to, this gives us a value 0.09090909. It's endless. So I want you to notice some of these fractions and you may give a comment on such. For example, this is endless. So we are looking at terminating fractions. So some of these they have an end. They stop at this point, whereas this 09090909 keeps on repeating itself. So the observation I want you to see here is if a fraction has endless values and if the values have an end, like in this example. Okay, now let's go to terminating, non-terminating, and recurring. So we have various examples that we have looked at as terminating, non-terminating, and recurring. We have looked at these examples. For example, if you have, so I'll use examples. For example, 1/11 gives us a value 0.090909 and other values. Then we have another example. 1/8 gives us 0.125 and it ends there. So when you look at this, we have said it has an end, and whereas this one does not. 0.9 is repeated over and over. So these ones, we call them non-terminating fractions. These ones are called terminating fractions. It should be noted that from the non-terminating fractions, because of the fact that the number keeps on repeating itself, in this example for 0.0909 etc. This value keeps on repeating itself, 090909. So that's called recurring. So the value 0909 keeps on recurring. So such fractions are classified as recurring decimals. Okay, so we have said that this is recurring terminating. So I want you to notice the difference, that there could be decimals that are non-terminating and are recurring. However, we also have decimals that are non-terminating but are not recurring. For example, we have looked at a number like 22/7. Remember, this is called pi in the knowledge of circles. This is called pi. So what is pi? 22/7 equals to 3.142857 and other values. So we realize that here we have 142857143. It is non-terminating, but not recurring. So what we observe in this section, we observe that we have three types of decimals, and these include, we have terminating decimals, we have non-terminating decimals. These are all decimals. However, non-terminating can be classified as recurring or not recurring. Here we have an example: 0.09090, 09 and other values. Here we've had an example: 3.142857143 and other values. So in this section, that is what we observe. Now you are going to do the exercise in this section. So next we are going to look at how to convert recurring decimals into fractions. We have these recurring decimals, how we convert them into fractions. If we are able to convert fractions into decimals, it means we can convert decimals into fractions. So let's see how to convert decimals into fractions. We have a decimal here, 0.333, and it is recurring because 3 is repeating itself several times. So how do we convert that into a fraction? So we are going to let this decimal be a number like x. So to be specific, we have used r. So we are going to let this decimal be r equal to 0.333 and other values. So how many numbers are recurring? It is only 3. It is 0.0909 etc. It was 2 numbers that were recurring. So, and here it is 1 number that is recurring. So that means it gives us 1 place value, and that means we have the 10. Okay? If it is 2 values that are recurring, then we have 100. If it is 3, then we have 1000. So this will depend on the number of values that are recurring. Still, we are using the knowledge of place values. So we are going to multiply each side by 10 because it is one value that is recurring. So we have 10 times r equal to 10 times 0.333 recurring. So this is 10r is equal to, so 0.3 times 10. We are going to move this here. So we have 3.333 recurring. So now the next thing we do is we want to remain with r, which is our decimal. We want to remain with r alone here. So it will be r equaling to 3.333 and the values out of 10. So call this equation 1, call this equation 2. So we are going to equation 1, equation 2 minus. So we are going to construct equation 1 from 2. We are going to subtract equation 1 from 2. We have 10r equals 3.333 and the values. So we subtract off r equals 0.333 and the values. So what do we get? Remember, all these values are 3. 3, 3, 3, 3, 3, 3, 3, 3, etc. So we are going to subtract all these values. 3 minus 3, 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 3 minus 3. And this gives us 0 all through. 0, 0, 0, 0 point. 3 minus 0, we get 3. 10r minus r. It means we are getting 10r and are removing 1r. So we remain with 9r. So we have 9r. So that's what we have. So I am going to above this part to ensure we complete our equation. So we have 9r equals to 3.000, etc. These zeros become negligible. So we have 9r equals to 3. So r, we are going to divide by 9. Even this side, we divide by 9. We remain with r equals to 3 out of 9. And this means that now we can reduce this by dividing by 3, 1 by 3, 3. So r is equal to 1 over 3. Now, 1 over 3 is a fraction. Therefore, 0.333 recurring is equivalent to 1 over 3 in fraction form. Okay. So you are going to be able to do the exercises. We have other activities. Now we are going to look at another activity which requires us to convert fractions and decimals into percentages and vice versa, percentages and decimals into fractions. So For example, we have 67 out of 100, and this is 67%. So this 67 out of 100 is 67%. If you have 13%, this will be 13 out of 100. This can be taken to decimals. We have seen those ideas. Now, question becomes, calculate a percentage of a given quantity. Now remember that we can have something called percentage increase or percentage decrease. So we can always do the calculations of any quantity and express them as percentages. So let's have an example. 10 times the 10% of 50,000. So we have our quantity. For example, it's money, 50,000. So what is 10% of that money? So 10%, we have said, is the same as writing 10 out of 100. So this means of is the same as multiplication. So 10% of 50,000 equals 50,000. So we can now reduce here and there and have 5,000. That's our quantity. Now, we have an activity to do which looks at students' marks scored in the various tests. So we have Julius scored 50 and 45. This is first test. Second test. They want us to, for each person, we calculate the percentage difference. They have given an example that if it is an increase or a decrease. So look at this. We have 50%, the first test, and we have 45%. So the percentage difference, we are going to get the difference between the two values, which is 50 minus 45. That is the difference, which is 5. So this scores, the table below shows students' marks in two mathematics tests. For each one, capture the difference, the percentage difference. Say if it is that. Okay, so we have 5. So 50 minus 45 out of 50 times 100 gives us 5 out of 50 times 100, which represents 10% increase in the marks from 50 to, this is a decrease, 10% decrease.